Alrighty guys, so another type of proof that you could do for proving triangles congruent is a two-column proof like we talked about before with our algebraic proofs. I kind of don't prefer it, but you can do it this way if you like to keep things organized like that, or if you don't like the squids, if they're kind of weird to you. So we're on page 45, 46, and we're going to look at 47, 48 as well in our notebook, and we're just going to do some of these examples here. So to prove triangles congruent with side, 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 I need all of the sides of one triangle to be congruent to all of the sides of the other. And so for instance here, maybe I know that these are congruent, and then congruent. Oop. And so then I can say that triangle ABC is congruent to triangle. So I went A to B to C. So I went over that pink line first. So E, F, D. Alrighty. So in my two-column proof, we're not going to do all these. I'm going to do the top two. Am I? Well, we'll do all of them. In this one here, it's given to me that all the sides are already congruent, like they were just marked in my picture. That was all given. And so therefore these triangles are congruent by side, side, side. Now the thing is, the two-column proofs that I set up for you, like they're not that easy. Like you have to fill them in. Like I'm going to write out given, and so you'd have to write that here, and then given. And then you would say the triangles are congruent in this case by side, side, side. So that one would be that easy. But maybe you have something like this one here where it's only given to you that JK is congruent to LM, so our one tick marky do's, and then JM is congruent to LK, our two tick marky do's. And I need a third thing if I want to prove those things congruent. And so by looking at my picture, I have this shared side right here, which is the reflexive property. And so I can mark that those things are congruent. And so this stuff was given to me. Now over here, I can say that JL is congruent to itself by the reflexive property. And because I have three sides congruent on each triangle, the triangles are congruent by side, side, side. This is easy. We can do all these. That's fine. Okay, so if it's given to me that EF is congruent to GF, I can mark that on my picture with the one tick marky. Now, if they say that H is the midpoint of EG, then I can mark in my picture that H is cutting EG in half, so each side is equal. But that's only two things. I need three things if I want to prove that triangles are congruent. And so by looking at my picture, I also have this reflexive side that each triangle has. And so since it's shared, it's congruent. And so I could say, firstly, I was able to mark my picture that EH is congruent to GH. And I was able to do that because I know what the definition of a midpoint is. Then I was able to mark in my picture that FG is congruent to itself. Oh, FH. Letters are hard. Numbers are easy. That FH is congruent to FH. And I can say that because of the reflexive property. And because my picture shows side, 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 I can say that the triangles are congruent by side, side, side. Alrighty, so down here, it's given to me that QR is congruent to QT, you little cutie. Okay, so that's what we got with the one tick marks. Then it says that QS bisects RT. So QS, this line, is cutting RT, that line, in half. And in half means that each side is the same. Now again, that's only two things that they've given to me, so I have to hope that my picture gives me something like a shared side, vertical angles, or something like that. I don't have vertical angles, but I do have this shared side, so I can mark that QS is congruent to itself. So first thing I marked in my picture was that RS is congruent to TS, and I was able to do that because I understand the definition of a bisector. And then I was able to mark in my picture that QS is congruent to QS because that is a shared reflexive thing. Reflexive, geez, spelling, words, letters. They're so dumb. So then I can say that the triangles are congruent because in my picture I have side, oh shoot, side, 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 side. So SSS. Okay. Now, we can also do side angle side proofs, doing the same thing. So, I mean, the front picture here is the same. It's our congruent statement. But this will be two sides and the angle in between. I'll mark it. Let's mark it. Let's do it. So, for example, we might have that AB is congruent to EF. And then AC is congruent to ED. And then it would have to be the angle where these two sides meet. So A and then E. Because if it's going to be angle side angle, like it has to be the angle in between the two sides. So, check this out. If they tell me that C is the midpoint of AD, ooh, I get to mark this stuff now. So C is the midpoint of AD. If I go on to AD and C is the midpoint, then that means it's cutting that equally in half. They've also told me that C is the midpoint of BE. So C is also cutting that line in half. But again, that's only two things. I need three things if I want to use one of my side to side, side angle, side shortcuts. So hopefully my picture will give me like a vertical angle or a reflexive property thing. And because I have two lines crossing in this picture, we can get that vertical angles are equal. So the first two things that we marked were that some sides were equal by the definition of midpoint. So I can kind of include that in one statement where I say that AC is congruent to DC, so that was the pink tick markies, and BC is congruent to EC, the orange tick markies, and those were both equal separately by the definition of a midpoint. Then I had to mark up in my picture that I had some vertical angles. So angle BCA is congruent to angle ECD because they were vertical angles. And then I can say that the triangles are congruent by side angle side. Okay, another one. Let's do this parallel line one next. Do that, looks fun. Okay, so they've told me that GH is parallel to, or I'm sorry, is congruent to, that was actually the first thing that they told us, this congruency stuff with the little tick markies. But then they also tell me that GH is parallel to FG. And so when I have that, I do have to pick a transversal. And when it's a picture looking like this, usually the transversal you want is the one in the middle because it's on both triangles. Okay, and that's super helpful because if we have parallel lines, then we can use any of those angle pairs. So usually we get alternate interior angles when this happens. And so we would be able to say that this angle is congruent to that one because they are touching the parallel lines and the transversal, and they're alternate interior angles. Furthermore, I have that transversal is a shared side, and so we can mark that as congruent to itself. And then I have my three things. I got side, angle, side. So cute. So the first thing that we marked was that pink tick mark thing, but we already had that. The second thing that we talked about were our parallel lines, which got me, and I'm going to add little numbers in here. I just think that'll be so much easier. I was able to say that angle 1 was congruent to angle 2 because they were alternate interior angles, and alternate interior angles are congruent when we have parallel lines, so that's good. Then I was able to mark that GJ was congruent to itself by the reflexive property. And so the triangles are congruent by side, angle, side. Alrighty. Another one down here. We'll do this one, and then I think I'm going to skip that one. We're good. But this one looks interesting. So the first thing that they marked for me was that KN was congruent to LN. So that was our 1 tick markies. Then they said that KL was perpendicular to MN, which is why I was able to put that there. But truly, it would be on the other side as well. And if they're both right angles, which that's what perpendicular means, then that means they are equal to each other. But again, that's still only 2 things, so I hope I have a third thing in my picture. And look at that little cutie, reflexive side. We sure do. Okay, so in my picture, we got side, angle, side. The pink side we already had. Now I need to say that angle M and L is congruent to angle M and K by definition of perpendicular. I may have actually jumped ahead a step. Like sometimes it's good to say that they're both 90 and then they're equal to each other, because the definition of perpendicular is really that they're 90, but it's okay. We can just go with this. The next thing that we marked is that NM is congruent to itself by the reflexive property. Yeah, see, I totally did that. No need for that step because that was like the 90 step. It's fine. And then I had side, angle, side to prove that they were congruent. Okay, let's try some angle, side, angles. Now, on angle, side, angle, kind of the inverse of what we just did, we got to have something like, okay, if I knew that A was congruent to E, and I knew that B was congruent to F, for it to be angle, side, angle, I have to have the side that's in between those 2 angles marked as congruent, and then we can use angle, side, angle. So that's important. So if we take a look at some of these, ooh, my parallel lines. Okay, we definitely don't need to worry about this scary picture. Don't worry. We also won't worry about that scary one. So we're just going to do the 2 top ones. I promise, guys, I won't give you crazy hard proofs. I never do. Okay, so if we look at this one here, we got those parallel lines again. So if they tell me that AD is parallel to BC, that's this one here. Oof, that one there. We're definitely going to want a transversal on both triangles. So that's this one here. Which then I need to start looking for that angle pair, and you're going to want the one that is inside the triangle and touching your parallel and transversal line. So here and there, which again are our alternate interior angles. Now the next thing that they gave to me was just angle BDC was congruent to ABD. So BDC. That little guy is congruent to ABD. That little guy. And then that's it. And that's only 2 things. You need 3 things. So hopefully your picture can get you that sneaky third thing that is going to be like a reflexive or vertical angle stuff that you can just look at your picture and tell. And you so have that. Your transversal is your reflexive side. And so the first thing that we marked were those purple angles. So we would say angle ADB is congruent to angle CBD because they were alternate interior angles. Then I marked the pink angles, but we already have that, so I don't need to say it again. And then we were able to mark that DB was congruent to itself by the reflexive property. And these two triangles are then congruent by angle, side, angle, ASA. Alrighty, let's try another one like that. So on this one here, they tell me that angle E is congruent to angle H. Boop, boop, straight up. Then they tell you that J is the midpoint of EH. So on EH, J is in the middle, cutting those boys in half. But that's only two things. You need three things to use one of your shortcuts. So you have to hope that your picture is going to give you a sneaky reflexive side or vertical angles, which in this case, we have two lines crossing at J. So those boys vertical angles, and vertical angles are always congruent. So first thing we marked was the orange angles. We already had that. Then I marked that these two things were congruent. So I need to say that EJ is congruent to HJ. And the reason I was able to mark that is because I know the definition of a midpoint. Then I marked in the picture that the yellow angles were congruent. So angle EJG was congruent to angle HJF because they were vertical angles. And so then the triangles are congruent by angle, side, angle. Alrighty, last one. We can use angle, angle, side, which is different, to prove that triangles are congruent. So for example, in my picture, maybe I know that angle C is congruent to angle D. And then angle B is congruent to angle F. If I'm going to use angle, angle, side to say that two triangles are congruent, you can't know that BC is congruent to FD. I mean, it will be, but that can't be the one that you're given. It would have to either be AC and ED or EF and AB. Either way. Let's go with the shorties. Because that side is not in between the two angles. So hopefully that makes sense. So if we take a little look-see here, let us do these two. I promise I'm not going to do the crazy ones. You'll never have to do the crazy ones. It's okay. Alrighty, let's take a little look. So first thing they tell me up here is that angle A is congruent to angle C. No, it looks like you could put a box there, but they didn't tell me it was 90, so I shouldn't. So straight up, those angles are just equal. Then they tell you that AD is parallel to BC. So I kind of like to always make my parallel lines a little longer. Then we got to pick our transversal, which should be the one that's on both triangles. So this one, yeah. And then we want to be looking for an angle pair that we can say are congruent and also inside the triangles. So I think this one and that one are the ones that we want. Now that was the only stuff that was given to me, and that's only two things. I need three things if I want to show that the triangles are congruent. So hopefully my picture will give me a sneaky third thing. It can't be another angle because that would be angle, angle, angle. So hopefully it's a side, and that transversal side again is a reflexive shared side, so it's congruent on both. So if we think about our picture again, I was able to mark the orange rainbows first, but I already have that written down. Then I marked up the purple rainbows, which I don't have yet, so I'm going to say angle ADB is congruent to angle CBD because they are alternate interior angles on parallel lines, which I already have. Then I was able to mark with the little yellow tick marky there that DB is congruent to itself by the reflexive property. And like I had a pause there because I don't know why I have this next reason, because I don't think we need it. Bye. Because then the triangles are congruent by side, by angle, side. Oh my word. Angle, side. I've made too many videos today. I'm always in the Nook Home shirt. Oops. Okay, one more in here and then we're done. I'm so sorry. This is a new video for you, but for me, this is my third one today. Love you. Okay. Sorry, I'm being goofy. All right. And this one down here, they tell me that angle S is congruent to angle U. S. U. Then they tell you that TR is bisecting SRU. So at R, because R is in the middle. So that's cutting R right in half. Boop, boop. That's a pink. However, that's only 2 things in your given, unfortunately, and you need 3 things. Always 3, because we got 3 letters. So hopefully your picture can give you a sneaky third thing. Probably a side is what you want because angle won't work. And luckily RT is shared on both triangles. So that's my third thing. And what we have here is angle, side. That side is not in between, like on the same triangle. So first thing I marked were the orange tick marks. We already have that. I was given it. I don't need to write it again. But then I showed that angle SRT. Oh, SRT. Is congruent to angle URT. And I was able to put those little pink rainbows on there because I understand the definition of a bisector. Then, again, I don't know why I have another reason here, but then I marked that RT was congruent to itself. Oh, bro. I'm glad I looked. Sorry, I'm having a moment. I'll come back with you. RT is congruent to itself by the reflexive property. I just realized it doesn't say triangles here. Triangle ADB is congruent to triangle CBD. And same thing here. I know what I'm doing, but you don't know what that's about yet. It's for later. Don't worry about it. That was the third thing that I needed to say that triangle SRT is congruent to triangle URT by angle, side. Please don't stress about that weirdness right there. I promise you don't need to worry about it yet. Okay, so those are 2 column proofs, and that's that. I will timestamp so that you guys can jump around. You're not going to listen to this necessarily unless you're watching the end.